it says a monochromatic light of wavelength 450 nanometer is incident on a double slit where d equals 0.3 millimeters. What is the angle of the second order maxima? If the screen is 12 meters away, what is the distance from the second maxima to the central maxima? Okay, I've talked about the theory of this a little bit before when I talked about interference when light waves come, and then there is two slits with a certain opening that are a distance d apart. This is called d. The light rays emanating from there interfere with each other, and they form a pattern here. Okay, the pattern is a continuous cycle of maximum and minimums. Right in the middle, you're going to have the central maximum, which is the brightest. Then you're going to have the first minimum. Then you're going to have the first order maximum. First order maximum. This one is called first order minimum. And then same thing is on the bottom. First minimum, first maximum, central maximum. This one will be second minimum, second minute, and then after that, second maximum. It's the third brightest one, but since the beginning center one is called central maximum, this is called first order maximum, second order maximum, okay? So the equation for this is what? And I've mentioned about this before. D sine of theta is equal to m lambda. This is for the constructive interference. M is equal to 0, 1, 2, 3, 4, so on and so forth. So d sine theta represents the difference of the path lengths taken by the two light rays, right? Where does that come from? Well, basically, if this is going to travel a certain distance and this is going to travel a little distance, right? This distance here is d, and if I make a triangle here like this, and then this angle is theta, or this angle is theta, so this distance here, this light ray is going to travel a longer distance, delta d, right? It's equal to d sine of theta, the opposite of that angle, right? So it looks like this. D, the top light ray is traveling an extra distance. This is theta. That's equal to d sine theta, right? So if that extra distance traveled by that top light ray is equal to an integer multiple of the wavelength of the waves, then you get constructive interference. Okay, constructive interference. Of course, we are assuming that all of the light is uniform wavelength. That's what this means, monochromatic. Monochromatic, everything is the same wavelength, right? The same thing was true for the top, of course. For the top, the bottom ray travels an extra distance, d sine theta. And if that extra distance is integer multiple of the wavelength, you get maximum, right? So in this case, we want second order maximum. Second order maximum is m is equal to 2. D equal to, in this case, it's equal to 0.3 millimeters. And then we have sine of theta. Then the m, we want to have the second maximum, so we put m is 2. The wavelength is equal to 450 nanometer. Okay, remember when we talked about the spectrum of the visible light waves, we said that 400 nanometer corresponds to violet, all the way going up to 700 nanometer corresponds to red. And then you had Roy G. Biv. Okay, so 450 nanometer corresponds to a visible light wave roughly in the blue range. So this is a blue light wave coming, and we want to observe its interference pattern here, and we want to study that. Okay, so let's analyze this now. Calculate the theta. Let me erase this part. So we write this in meters. 0.3, a millimeter is 10 to the minus 3 meters. We have sine of theta. We have 900 times 10 to the minus 9. A nanometer is 10 to the minus 9. And the 2 I multiplied by 450, right? So we have sine of theta is going to equal 9, 2 zeros. This is 10 to the second times 10 to the minus 9, 10 to the minus 7, divided by 0.3 times 10 to the minus 3. Now, 0.3 times 10 to the minus 3, we could go 1 over here, right? Then this one will become what? 10 to the minus 4, right? So 3 times 10 to the minus 4. 9 divided by 3 is just 3. 10 to the minus 7 or 10 to the minus 4, that's going to be 10 to the minus 3. You subtract the 7 and the 4, you get 3. So 172 degrees. Okay? So now, if the screen is 12 meters away, what is that distance? Right? So if this angle is 0.17 degrees, how do we calculate that? So you have this slit is like this. This is going to be like this. So the little slits is like this. This is 0.3 millimeter. We found out that this angle from the center to the second maxima is 0.172 degrees. Right? This one, the distance to the screen is 12 meters. Right? We want to know this distance. So what do? We say tangent of 0.17, right? This we can call it x. Tangent of 0.172 degrees is equal to x over 12 meters, right? And then we can calculate that. So what I'm going to do is take the tangent of the angle that I just obtained from the calculator in the unrounded form. Now what ended up happening is tangent of 0.172 came out to be 0.0030000135. So in other words, the tangent of an angle when an angle is small is just about the same as sine of an angle because the angle is very small. So the sine of an angle was 0.003. The tangent was also, tangent of 0.172 was also 0.003000135. So for most purposes, we could have also taken just the sine, since the angle was so small, right? And then sine would have been 0.03. And then 0.03 times 12, 0.036. So that would be what? 3.6 centimeters. Okay? 3.6 centimeters. So that's actually something measurable. This is something that we could do in the lab. Shoot a laser beam or some kind of source of light, split it, and we would have a measurable distance there, 3.6 centimeter, and from there we could do calculations, right? What would be the distance to the second minimum or the first minimum? How do we do the minimums? Well, for minimums, we've got to use what equation? For first order minimum, we would put m is equal to 0, right? M is equal to 0. That's the first minimum that you get, right? Or what you could do is you could say m minus half lambda, and then you would start with m equals 1. You see? Right now you wouldn't start with m equals 0. So it's basically up to you how you want to define it. You could say m minus half, start with 1, 2, 3, 4. M equals 1 would be first order minimum. Or you could do plus half, then you would go 0, 1, 2, 3. This would be first order minimum, second order minimum, third order minimum. So in order to not confuse the student, it's probably better just to say m minus half, and then don't start with 0. First order minimum, second order, third order, fourth order, and so on. So that's better that way, right? So if I wanted to know the angle to the second order minimum, what would I do? D sine theta, I'll put 2 minus a half lambda. So this would be 0.3 millimeters sine theta. This would be what? Faster. you just say 1.5 times 450 divided by 0.3, and then just do the powers of the 10 yourself, times 10 to the minus 6. So 1.5 times 450 divided by 0.3 times 10 to the power negative 6, 0.00225. Sine theta, 0.00225. Take the inverse sine, 0.129 degrees. 0.129 degrees. Okay, now take the tangent of that. Well, tangent and sine are going to be the same. Officially, let's just take tangent. Tangent. And then multiply that by 12 meters. 0.027. So the distance x is going to be 0.027 meters. So the other one was what? 0.036. So this is 0.027, 2.7 centimeters, right? So this is going to be 3.6 centimeter. This one is going to be 2.7 centimeter, and then so on. You could do first maximum, first minimum, and then of course central maximum is itself, okay? Sometimes the way that this question might be worded to you is this way. They might say, what is the thickness of the central maximum? Okay? Well, the idea for that is you have to find the distance to the first minimum and then double that, right? Find the distance to the first minimum, double it. So what you would do is you would put here 1, and then you would put 1, and then you would get half, and then you would get just half here, and then what you would do is you would get, instead of 1.5, you just have half, right? So your answer here would be at 0.00075, 1/3 of that, right? 0.75. Then you calculate you can calculate its corresponding angle, but right now I'm just interested in the distance. Take that and take the tangent of it is going to be pretty much the same in this case. So take that and multiply it by 12. 0.009. Okay? So you see what ended up happening? And the second minimum is 0.027. This one is 0.009. So what's going to be the thickness of the central maximum? Double 0.009. 2 times 0.009, 0.018 meters, which is 1.8 centimeters. Okay, so the central maximum is going to be the thickest. 1.8 centimeters. The thickness of this is going to be a little bit less, a little bit less, a little bit less, a little bit less, and so on and so forth. So you can do all kinds of problems with these kinds of questions, okay? And analyze interference patterns like this. So now you know how to approach these kinds of problems overall, okay? Thank you very much.